Data structure. A data structure is a particular way of organizing data in a computer so that it can be used effectively. For example, take a boutique where clothes are separated by forms, colors, and types for easier access and usage. The idea is to reduce the space and time complexities of different tasks. The choice of a good data structure makes it possible to perform a variety of critical operations effectively. To store the possible moves in a chess game. To store a set of fixed keywords, which are referenced very frequently. To store the customer order information in a drive-in burger place are few daily examples of data structure. There are two types of data structure: linear and nonlinear. Linear data structure. Elements are arranged in one dimension, also known as linear dimension. Example: lists, stack, queue, etc. Nonlinear data structure. Elements are arranged in many and many dimensions. Example: tree, graph, table, etc. Most popular data structures. 1. Array. An array is a collection of data items stored at contiguous memory locations. The idea is to store multiple items of the same type together. This makes it easier to calculate the position of each element by simply adding an offset to a base value, i.e., the memory location of the first element of the array. 2. Linked lists. Like arrays, a linked list is a linear data structure. Unlike arrays, linked list elements are not stored at a contiguous location, the elements are linked using pointers. Stack. Stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, last in first out, or FILO, first in last out. In stack, all insertion and deletion are permitted at only one end of the list. Queue. Like stack, queue is a linear structure which follows a particular order in which the operations are performed. The order is first in first out, FIFO. In the queue, items are inserted at one end and deleted from the other end. A good example of the queue is any queue of consumers for a resource where the consumer that came first is served first. The difference between stacks and queues is in removing. In a stack, we remove the item the most recently added. In a queue, we remove the item the least recently added. Binary tree. Unlike arrays, linked lists, stack, and queues, which are linear data structures, trees are hierarchical data structures. A binary tree is a tree data structure in which each node has at most two children, which are referred to as the left child and the right child. It is implemented mainly using links. These are the basic concepts of data structures.